In 1869, a scientist predicted 3 elements that didn't exist yet, and got their properties right to within 2%. By the mid-1800s, chemists had discovered about 63 elements, but had no idea how to organize them. It was like having 63 puzzle pieces with no picture on the box. Mendeleev's key insight: when you line up elements by increasing atomic mass, their properties repeat in a regular cycle, like a musical scale that resets every octave. So Mendeleev built his table, rows and columns organized by this repeating pattern. But when he tried to force every known element into the grid, something strange happened. The pattern demanded gaps. If Mendeleev forced an element into the wrong spot to fill a gap, its properties clashed with its neighbors. The gap had to stay empty, reserved for something undiscovered. Think of it like a street with house numbers. If you see 10, 12, then 16, you know number 14 is missing. You can even describe the house before you've seen it. Mendeleev named his 3 biggest gaps Eka-boron, Eka-aluminium, and Eka-silicon, Eka meaning one beyond in Sanskrit. He predicted their atomic masses, densities, and even how they'd react. In 1875, just 6 years later, French chemist Lecoq de Boisbaudran discovered gallium. Its density, Mendeleev predicted 5.9 grams per centimeter cubed. The actual value? 5.91. That's a 0.2% error. Scandium arrived in 1879, germanium in 1886, both matching Mendeleev's forecasts with stunning accuracy. The scientific world that once mocked the gaps now called him a prophet. Here's the aha moment. Mendeleev didn't memorize chemistry. He found the pattern hiding inside it. The gaps weren't failures of knowledge. They were the shape of knowledge yet to come. Mendeleev's gaps taught us that a great theory doesn't just explain what exists. It predicts what must exist. If that blew your mind, the story of how atomic structure finally explained why the table works will too. Subscribe, and we'll take you there.